Okay everyone, so this is our third lesson on expanding double brackets, and we're going to be expanding and simplifying some slightly trickier expressions, and we're still going to be using the grid method to help us. So this first example here, you'll notice that in the examples we do today, you will have your variables, so your letters, will have a coefficient. So here we have 3a multiplied by 3a plus 2 multiplied by, so all of that, multiplied by 2a subtract 4. Okay, so when we complete our grid, we have 2a multiplied by 3a, which would be 6a squared. We have 2a multiplied by positive 2, which is positive 4a. 3a multiplied by negative 4 is negative 12a. And negative 4 multiplied by positive 2 is negative 8. Then we are going to add everything in the grid up and then simplify at the end. So when I add everything in the grid, I get 6a squared plus 4a subtract 12a subtract 8, and then I can see that these two terms here are like terms because they have the same letter and the same power. This has a squared in it, so it's not like terms with them. So my final answer is 6a squared subtract 8a subtract 8. Example B, this looks slightly different as well because we have 3a plus 2 all squared. Now when we square something, that means we multiply it by itself. So this question is actually asking us to do 3a plus 2 multiplied by 3a plus 2. Okay, so that's what we're trying to do. So we're going to draw out our grid. So we've got 3a plus 2 multiplied by 3a plus 2. And completing the grid, we'll have 9a squared here, positive 6a, positive 6a, positive 4. Adding everything up is 9a squared plus 6a plus 6a plus 4. And then my like terms I can see are my plus 6a and my plus 6a. So those will need to be collected to get my final answer, which would be 9a squared plus 12a plus 4. And remember, we usually write it in the order of our square term, then with the letter squared, just the letter and the number on the end. So that's the order we would write it in. And the third example, it's not really any different, but you'll see here we've got 4 subtract 3a and multiplied by 2 subtract a. So our letters here are negative, as in most of the examples we do, the letters are variable positive. So that's the only difference here. So I'm going to use my grid. And I've got 4 and subtract 3a. And then I've got 2 subtract a. And now I'm going to complete my grid. So 2 multiplied by 4 is 8. Now there's no positive or negative sign in front of these, and that means they're positive. If you don't see a sign in front of them, then you assume they're positive. So this would be positive 8 in here. Then positive 2 multiplied by negative 3a is negative 6a. Positive 4 times by negative a is negative 4a. And negative 3a multiplied by negative a is positive, because a negative times by negative is a positive, 3a squared. So I'm going to add all of these things together, and remember I'm going to put my square term first. So I've got my positive my positive 3a squared. Then I'm going to leave the number till the end, remember? So negative 6a, negative 4a, and positive 8. And then my like terms are these two terms here. And that gives me 3a squared, subtract 10a plus 8. That's my final answer. And we have two slightly longer examples, but they are using exactly the same skills. So, you can see this example here. We have 2a plus 3 multiplied by a plus 8. Now all of that is being added to 4a plus 1 multiplied by 2a plus 3. So what I'm going to do is I'm going to multiply these two brackets together, find out what it equals to. Multiply these two brackets together, find out what that's equal to, and then I need to add them. So there's just a few more steps here, but it's not anything different. It's not anything different to what we've been doing. So I'm going to do these grids just out of the way. So I'm also going to do them a little bit smaller than I usually do. So I'm doing 2a plus 3 and I'm multiplying that by a plus 8. And this is going to give me 2a squared, positive 3a, positive 16a, and positive 24. So when I add these things, I get 2a squared plus 3a plus 16a plus 24. And then collecting my like terms, I'm going to write the simplified expression underneath here. So underneath this bit. So it's 2a squared plus, and then 3a plus 16a, positive 3a plus 16a is 19a plus 24. So that's these two brackets multiplied together. Now I'm going to separately do these two brackets. So I have 4a plus 1 multiplied by 2a plus 3. And then completing this grid gives me 8a squared here, positive 2a, positive 12a, and positive 3. And then adding everything together is 8a squared plus 2a plus 12a plus 3. And then collecting the like terms, I'm going to write this underneath here, so I'm going to go back to my original expression. So I've got this whole thing, and I'm adding it to this one. So 8a squared plus 14a plus 3. Now you might be thinking, why have you put brackets around those things? Well, the reason why I've done that will become clear in the example below, because in the example below you can see that they're being subtracted and that has an effect. But because these two are just being added together, that's fine. We can just start collecting like terms now. So I can see, I'm going to get my multicoloured pen because I've got lots of like terms. I can collect together 2a squared and 8a squared. Okay, now they're both positive, so they collect together to give me 10a squared. Then I have positive 19a and then positive 14a. They can be collected together as well. They are like terms. But they're not like terms with these green ones, because these green ones have a squared and these ones have a. So 19a plus 14a is plus 29 plus 33a. And then I can also collect together the numbers, can't I? I can collect together positive 24 and positive 3. So these oranges collect together. The oranges collect together to give me plus 27. So that whole expression up there in the highlight simplifies down to 10a squared plus 33a plus 27. And we have one more example. So example E. So I have a plus 9 all squared, subtract 2a minus 4 multiplied by 1 minus a. So again, I'm going to do a separate grid method for this one over at the side, separate grid method for this one over at the side, and then I will do the subtraction. So we first need to do a plus 9 all squared. Now remember, a plus 9 all squared is equal to a plus 9 multiplied by itself. So our grid method will be a plus 9 multiplied by a plus 9. So we have a times a is a squared plus 9a plus 9a plus 81. Adding all of those together, so a squared plus 9a plus 9a plus 81. And I can see that I have like terms here that can be collected together. But I'm going to write that over here. So I get a squared plus 18a plus 81. So that's the first bit. That's what I get when I do a plus 9 all squared. And now I want to subtract the next thing. Okay, and the next thing is going to be 2a subtract 4 multiplied by 1 subtract 8. So I need a grid method for that. And I'm doing 2a subtract 4 multiplied by 1 subtract a. So filling out my grid, well 1 times 2a is 2a, and 1 times negative 4 is negative 4. And negative a times 2a is negative 2a squared. And negative a multiplied by negative 4, so negative times negative is a positive 4a. Right, now adding all these up, and I'm going to be putting my square term first. So I've got negative 2a squared plus 4a plus 2a subtract 4. And my like terms are the plus 4a and the plus 2a. And when I collect them up, I'm going to write it over here. So I've got negative 2a squared. I'll get positive 6a when I collect these two together. And subtract 4. Now this is where these brackets that I've drawn here comes in important, because when I was simply adding all of the amounts together, then that was fine. I could have actually just not drawn the brackets, but here when I start to do my like terms, I can see I've got a squared over here, but over here I want to subtract negative 2a squared. So this subtract here has an effect. It essentially multiplies this whole bracket by minus 1. Okay, so I'm going to rewrite this expression. This one doesn't have anything happen to it, this one is fine. But this one is being multiplied by negative 1, so negative 1 multiplied by negative 2a squared is actually positive 2a squared. And negative 1 multiplied by positive 6a is negative 6a. And negative 1 multiplied by negative 4 is positive 4. So when you have this subtract, you need to make sure you multiply everything here by that negative 1. So now we can start to collect like terms. So I can see I've got a squared and positive 2a squared. And they will collect together to give me 3a squared. Then I have positive 18a and negative 6a. And they will collect together to give me positive 12a. And lastly, my two numerical values can be collected together, so positive 81 and positive 4. And they will collect together to positive 85. So this is my final answer when I expand and simplify this expression.